And the run here was 2 hours, wasn't it? And if you reduce 80 divided by 2 is 40 miles per hour. So you would say 40 mph. Right? That's a concept we can all kind of relate to, isn't it? Now, does that mean that you were going 40 miles per hour every point in time? Like you're driving, you look down at your speedometer, was it reading 40 the entire time? No. Sometimes you might have been going 60, and then other times 35. Sometimes you might have stopped. Right? Yes, but you could accelerate, but then you could also slow down. You could stop, and then it comes back to zero, right? So the point is, though, that at every instant in time, you weren't going 40 miles per hour on your speedometer. So the question becomes then, can you talk about the speed of something at an instant in time? Like I know when I look down at my speedometer, I'm driving, I look down there, it's telling me how fast I'm going right then. But how do you get that from a graph? Like if I pick some value here, let me just pick this one right here, and I'll call it X. And I come up here to my graph, and I say right there at that point, how fast was I going? It turns out that you need to have some idea, like that green line, right? We can find the slope of that, and that gives us an average speed. If we try and find the speed of something at one point in time, what happens? Think about your total, like if I say, and I like to throw things, so let me throw this through everyone just watch out over there, okay? Like if I throw this through the air, it's going to go a certain distance over a certain time, right? Ready? Here it comes. Right there, when I clapped, right? Y'all heard it? When I clapped, how fast was it going right then? Well, right when I clapped at that instant, right there at that instant, what's the distance it's traveled at an instant? It's not, right? So at an instant in time, the distance you go is zero. How much time elapses at an instant? Nothing. No time, right? 0 over 0. 0 over 0 makes no sense, right? Makes no sense. So it seems like you can't talk about the speed of something at an instant in time because you get 0 over 0. But what we've discovered with these limits is that it's okay if you get 0 over 0 if you have some way of looking at what's happening as you get closer, right? Near it. And we've seen problems where we get 0 over 0 and we're able to still come out with a numerical answer. Does that make sense? And that numerical answer is your instantaneous speed, your speed at an instant. So Isaac Newton and Leibniz were trying to get around the idea of division by zero. How can we work around it? And that's where it was born. The limit came from that, and then you can answer a lot of things and do a lot of things with it. But that's just a little background for you, just to kind of get you at least somewhat interested in what it is this is all for. Yeah, and then physics, and yeah, there's a lot of things. I don't want to open up the box too much right now, but just know it's useful. Number 22, limit. U goes to 2, square root 4u plus 1 minus 3 all over u minus 2. I'm going to go to full screen mode here because I'm going to need some more space. All right. Here's where the algebra starts to get tricky. First of all, what is this headed towards? So plug in 2, you should get 9 underneath that root. Square root of 9 is 3. 3 minus 3 is 0. On the bottom, 2 minus 2 is 0. So you should get something of the form 0 over 0, which we've already said is a bad thing. It's actually a good thing because, you know, now we can do calculus stuff, but in general, it's just bad. So the things that we've done with the algebra so far is factoring has been very useful, right? And there was one where I had to expand that one, that 2 plus h cubed, where I had to multiply it all out, and then luckily those 8's canceled and life was good. This one you can't factor. This one you can't expand. So what do? I mean, there's nothing that I don't think anyone would naturally just, oh yeah, sure. Like if this is your first time ever seeing this, like be like, oh yeah, just do that. So let me show you what I'm going to do. I'm going to multiply this by 1. And not just any one, a very, very special one. And remember, anything divided by itself is 1, isn't it? So I'm just going to put something in place of that 1 that is something divided by itself. And look what it's going to be. I'm going to rewrite limit. You don't want to get lazy with this, all right? I know your hand will probably start to hurt at some point, and no pain, no gain. So here comes my 1. I'll even do it in blue so it's color-coded. How cute is that? Okay, here comes my 1. Gosh, I can't draw a straight line for my life. I'm going to multiply. The 1 is going to be something over, so it's going to be the conjugate of the numerator. The conjugate is the same as the numerator, but instead of having a -3 between the two terms, I put a +3. So I would call this an algebra / trick, more of a trick than algebra, right? I mean, like factoring, that's algebra. This is more of a trick. Yes? U minus 2 over U minus 2. You mean multiply top and bottom by U minus 2 over U minus 2? Yeah. That's a great question. How about this? Let me work this through and you'll see what's going to happen. See, the square root's the thing that's the problem. And ultimately what I'm trying to do is get rid of division by 0, right? By coming in with the conjugate on top and bottom, I should get rid of the square root on the top. All right? And let me write something on the side here. Look at this. If I write A, if I have A plus B, right? If I just have that just sitting there, and I multiply it times its conjugate, which is A minus B. So anytime you have two terms, and you multiply by its conjugate, which would be the same thing but switch the signs, what happens? A squared minus AB plus AB minus B squared. So what goes away here is the middle, right? And all you wind up with is the A squared minus the B squared. So what I'm going to wind up having is that root is kind of like the A, is going to be squared, and so the square root's going to vanish. So let's try it. Is that okay if I just try it? All right. There's another answer for you, okay? Why not do the U minus 2? Because it won't work. You could do it, but it's not going to help. I mean, when you multiply something by 1, you can pick anything in the world you want, okay? But that won't work. This does, and I'm showing it to you. Now you've been exposed to it, and so now you know that anytime you see square roots like this, I could pull that trick out. It's a conjugate, might actually work, all right? So let's try this. I'm going to put parentheses around both the numerator here, both numerators, and I'm going to do a FOIL. What's the root of something times the root of the same thing? The roots go away, what's underneath is left, right? So all you get is what from that? 4u plus 1. Now, the next multiplication is going to give me, and I'll write it out, plus 3 root 4u plus 1. So it's just the 3 times that root, isn't it? What's the next multiplication give me? That's the inner ones. Minus 3 root 4u plus 1. And then what's the last multiplication? Minus 9? All divided by, now this is where things get a little freaky here, the denominator. I recommend you do not multiply out. Just write u minus 2 in parentheses next to the square root 4u plus 1 plus 3. Okay, so I did multiply out the numerator, but I did not touch the bottom. I just put the 2 next to each other in parentheses. Is that all right? Does everyone see the middle thing that cancels? The middle terms cancel. Yes, I'm going to put equals. Yes, I'm going to put limit. That limit's going to stay with me until I make the substitution, right? I get the 4u, then plus 1 minus 9 is actually 4u minus 8 all over the u minus 2 times square root 4u plus 1 plus 3. Now, have you all noticed that in every problem that we've done, whenever we've had like 0 over 0, we've always been able to factor and cancel something? That should happen here too. But it's not ready yet. You have to do one more thing before anything's going to cancel. Do you see it? What is it? Factor out the 4 in the numerator. That leaves you with the u minus 2 on the bottom. There's that u minus 2. And then you have the square root 4u plus 1 plus 3. Then cancel the factors. I'm not going to rewrite it now. I'm going to do my direct substitution now. I'm going to try it. Once I get that factor to cancel, I'm going to try the direct substitution. And let me put in equals because I'm praying that it's going to be a number. I'm not really praying, but you know what I mean. What do I get in the numerator? 4 over, now u is 2, isn't it? So square root 9, 3 plus 3, 6, 4/6. That's a number, 2/3. I'm a happy man. 2/3. So that's your first kind of trick, all right? Conjugate. No questions? 24. How do you think you're going to get comfortable with all this? You're going to have to do these problems, okay? You're going to have to get your hands dirty. This is definitely a class where you cannot just show up, watch me, and be like, I'm good. I could do that. No problem. T goes to 0. What are we getting here? 1 over 0, right? Let me write down the form of this. I'm getting 1 over 0 minus 1 over 0 again, right? Isn't that like fixed over 0, fixed over 0? Yeah? It's a mess, right? It's a mess. And so let me try a little bit of algebra first, all right? Let me try some algebra to see what happens. Any ideas of what you could do with that algebraically? What's that? Get a common denominator. Try and put those two fractions together. Now, before I put them together, let me factor the denominator on the second one. The reason I did that is because you could technically say now that both denominators have a t in them, right? The only thing missing is that in the first fraction I need to introduce what? A t plus 1. So I'm just going to stick a t plus 1 right in there, and a t plus 1 in the top. Right? Whatever you do to the bottom, you have to do to the top there. So it would look like this. This would be a line you don't have to write, but I'm just, this is